Okay, in this video, we're going to detail completely all transformations of a function f of x using function notation. Uh, so we're going to help make sense of this, each part of this function, which was originally just f of x, causes some transformation on the graph. And we're basically going to show where each one of these transformations take place. So I'm going to start by going to the calculator. So just going to the calculator, and I'm going to define f of x. Okay, all right. Let's use the absolute value function. So I'm going to go menu 1 1, menu 1 1, and I'm going to define f of x as the absolute value. I'm just using a weird function. So absolute value of x, and we'll just press enter. All right, just we can change it to anything that we want. Okay. Now that we have f of x defined, we can go now to our graph, and I am going to make f1 of x to be f of x. So I'm going to variable, enter, and f of x. Okay, so that's the absolute value function, and which is our f of x. That's our parent function. So now let's define another function. Now let's look at all the transformations of f of x. Okay, so go to f2 of x. First transformation we'll look at is we'll change the value of a. So I'm going to talk about, let's keep it simple. What does negative f of x look like? So I'm going to go negative f of x, right? We'll get to a in a minute. All right. So when you make f of x negative by putting a negative sign in front of it, it gives you a reflection about the x-axis. So this is a reflection. So f of x, so negative f of x, I'm just going to see if I can just make this, f of x is reflected about the x-axis. That's what negative f of x does. It reflects f of x, so about the f-axis. So the first transformation we talked about is reflection. All right, the next reflection of f that we're going to look at is what happens if we take f of x and we multiply it by some number a. So a of f of a, not a of f of x, but a times f of x. All right, what happens? And so we need to create, I'm creating a slider. So we're just going to put in different values of a here. So, and I don't want this to take up a whole lot of space, so let me minimize this. All right, so notice that if a is 1, nothing changes, because multiplying anything by 1 doesn't change it. But what if I let a be bigger than 1, like 2? What happens when a is 2? Well, when a is 2, the graph gets skinnier. That's what it is. Let's compare this with the original graph so that we can see. So I'm going to put the original graph back in here. That's in blue. That's our parent function. Look at our transform function. It's skinnier because a is 2. What if I let a be 3? Even skinnier. What if I let a be 10? Even skinnier. So as long the bigger a is, if a is greater than 1, the graph is going to be skinnier. It's going to be made more narrow. We call that a vertical stretch. So if a is greater than 1, you have a vertical stretch. Now, what happens if A is less than 1? All right, well, in this particular case, let's let A be, I'm going to let A be like 1/2. So I'm going to put a 1/2 in here, or 0.5. I'll just make it 1/2. But if A is 1/2 between 0 and 1, now you see the graph is getting wider. So, and if I notice that as long, if I let A get smaller, let's make it 0.1, it's very, very wide. Now, what if I let it go negative? Then we're reflecting it again. So, so we got 3 things to that we know about A. If A is less than if A is between 0 and 1, you're going to have a vertical compression. That's what we call it, compression. All right. Keep in mind that if A is negative, you're going, if A is negative, which is the same thing as just putting